Hey guys, grading the first question here. So basically, let's zoom in on a couple things. Alright, grading part A. Now keep in mind you need to grade these in pen, and please put the number missed at the top of each page. A, the area of R, we're thinking integration. You get a correct point for the correct limits. -3 and 3, you could have solved it by setting it equal to each other, but you could have did calculator intersect too. Point for the integrand, which is this. Point for the answer. This is truncated, this is rounded. Truncated is just chopped off. No rounding, just chopping decimals. Okay? There we go. B, volume of the solid generated when the R is rotated. This is the, should be big radius minus small radius. Okay? 2 points for the integrand. Now you could have wrote your big radius minus your small radius like this. Pi, correct limits. Boom. Big radius minus pi, limits, small radius. Or you could have changed 1 to f of x, 1 to g of x, and done it like this, or even like this, where f of x here, g of x here. Remember, calculator active question, give me an answer, right? 2 points integrand, 1 point answer. Please put the number missed for each section. Okay? Now, kind of complicated, right? Volumes of solids with known cross sections. Okay, basically you start here. This is what you got to know. Okay, if you tried to figure out your radius and you started with this, you're in the right direction. So we're integrating little half circles. All these are just millions and trillions and quadrillions of half circles, right? So that's what we're integrating. So we just got to figure out what a radius is. Well, that's what it is. The difference between this y and this y, right? But it's a half. So you plug that in, and I don't care if your answer looks like that. If you did plug this into R and you squared it, and you could have made this y sub 1 with all the 1/2 and the pi, or this y sub 1 with all the 1/2 pi and all that factored out, I don't care. As long as you plug this in and you got the correct answer, but you got to show this plugging it in. You can't write it off to the side and leave that. You've got to actually substitute it. Otherwise, you don't get a point. I would take off a point from the integrand if you just wrote this. Alright guys, that's it for this one. Let's move on. Complicated problem now. Complicated problem. Alright, so I'm going to do a little explaining, a little just plain grading as we go. So, I'm not even looking at the graph. I don't really care about that. But, so, letter A, how many gallons of water enter the tank? Well, we're given a rate. We know if we integrate a rate, we get the actual value, the position. So if we integrate how fast the gallons are moving, we actually get the gallons. That's a cool way of saying it. I probably should have said that earlier. But if we integrate how fast the gallons are going, then we get the number of gallons. So how many gallons of water enter the tank, we're going to integrate that. So all you had to show was that. But if you actually plugged in the whole shebang, then that's fine too. Point for the integral, point for the answer. Letter B, the amount of water in the tank is decreasing on those intervals and those intervals. Well, why? Because the amount of water in the tank is the inflow the rate of the inflow minus the rate of the outflow is the total rate in the tank. So rate of the inflow minus rate of the outflow. Okay. And guys, please make sure that you're on your honor. I don't want you to copy down the answers to this, because here's two things. I want you to go back and work them out. I want to see that you've worked them out, and I want you to get the benefit. So make sure that you're grading these appropriately. Okay, so rate of inflow minus rate of outflow. Rate of inflow minus rate of outflow is the total, how high the tank is rising, or how fast the tank is rising, or how fast the tank is dropping. So if I integrate that, if I integrate the total rate, I get the total, I guess I'll make it G, the total gallons. So I want to know when the total gallons are decreasing. Okay, so I want to integrate that. Well, I can't. I'm sorry, I just got off track. I don't need to integrate that. I just look at my rate. If I look at my total rate, then when it's negative, it's decreasing. Okay? So here, sorry. Alright, they said the intervals here and here when it was decreasing, because f of t is less than g of t. Well, that's the same thing I said. Alright? If this is negative, then it's decreasing. Well, I think the AP readers would understand either. All right, if f of t is less than g of t, then this is going to be negative for there and there. And you can put this in your calculator, right? Or just look at it here on the graph, right? And say, oh, well, the total amount's dropping. Yeah. Okay. So as long as you said that. You got to give your reason. Your reason does not have to be this. It does not have to be f of t minus g of t is negative. But if you gave a good reason that basically means the same thing, give yourself a point and bring it to me tomorrow, and we'll talk about whether or not you get that point. Okay? All right. So, all right, back here. Yeah, that's about that. All right. Now, all this stuff. Here, you want to find the amount of water in the tank greatest. So we want an absolute max. So our rate. Now, what rate are we talking about? This one, or both? Both. Inflow minus the outflow. So f of t minus g of t. Alright, is f of t minus g of t. We want our rate, right? This is kind of like the derivative. Think of this as the derivative. We want our rate to go from positive to 0 to negative, right? Well, think about f of t minus g of t. Which one's f of t? Let's see. This is f of t. Alright. When's f of t minus g of t going to be positive? Think about it. F of t minus g of t. When's it going to be positive? Alright. Well, it's not going to be positive right here. This is g of t. There it's going to be negative. Here it's going to be positive, positive. Bam! Negative right here. So, since f of t minus g of t changes sign from positive to negative only at t equals 3. See, this is a great global argument right here. It only changes sign from positive to negative at t equals 3. So this covers the whole domain. It's awesome. All right, the candidates for the absolute maximum are 0, 3, and 7. Why 0 and 7? Why the endpoints? Well, remember 8 years ago, when we will learn the EVT, the extreme value theorem, say we include candidates for absolute maxima or minima are the critical points and the endpoints. So we plug them in. Now, at times 0, the gallons was 5,000. At times 3, we're going to have to integrate the inflow minus the outflow. Right? And the outflow from 0 to 3, if you look up here, was 250. Integrate it. Calculator. Boom. Calculator. Boom. Obviously, that's the largest one. It's a 5-point question. All right, go ahead and grade this. Guys, you're on your honor. I would rather you not write down the answers so you can go back and do them yourself after you've gotten a little primer right here. And be ready to turn this in first thing tomorrow when you walk in. Graded. With the number missed at the top, please. All right. Last thing. When y'all turn in your multiple choice there, multiple choice, please have those ready to turn in. I'm going to have those little bubble sheets, okay? Little bubble sheets for y'all to bubble in, or I may just do it on my own. I don't know. Just be ready to turn them in tomorrow. I'll see y'all tomorrow. Bye.